proud to present my research about OpenShift. I will talk a bit about how OpenShift environments can be configured in a right or wrong way. First of all, I will introduce myself. I'm working as a security consultant in a security company called ERW in Germany. Worked former as a security analyst, pen tester, web app monkey, I like to say, and even social engineer. Did my master degree in IT security in Darmstadt, and my current field of research is Kubernetes on-premise solutions, kind of cluster extension, what you can deploy within the cluster, and in my free time I like to garden a bit. What's on the agenda for today? First of all, I will start with a comparison between OpenShift and Kubernetes. What's OpenShift and what's the extension? Then we will talk a bit about threats, what's are actual threats for the cluster. And then we go through the security or insecurity of the cluster. And then I summarize it up and will explain some future work. OK, first we will start with a short introduction about Kubernetes, OpenShift. OpenShift is an on-premise container execution platform from Red Hat, what you can use to span up a cluster. It was initially released in 2011, and his current stable release is on 4.2. It was in November this year released. Under the hood, it's building up on Red Hat Enterprise Linux and is now shifting over to CoreOS, which is acquired by Red Hat. Since the version 3, it's built up on Kubernetes. Beforehand, it was built up on its own container runtime engine, like orchestration engine. And now we have Kubernetes under the hood. And since version 4, we do not use Docker anymore within OpenShift. There is now CRI-O used. And yeah, there is even something called the OKD. It's a community version of OpenShift, which can be used by everyone and can spin up your own OpenShift cluster at home. Like, for example, if you use CentOS for Red Hat in comparison. This current stable release is from 2018, last year in October, and it's built on Kubernetes version 1.11. It's all a bit older. They try to take it now on the new version 4, but it's still work in progress. During my research, I used the community version so that you are able to reproduce the research also on your own. But in some cases, I will come to this later. First of all, we will talk a bit about Kubernetes. Kubernetes offers you something called role-based access control, where you can define per role within roles what kind of cluster access should a user have. Means what kind of API objects you want to modify and what kind of changes can be done within the cluster. Then you have called something like namespaces, where you can have a soft boundary between different projects, resource limits and security context, where you might access sensitive information from the host operating system, network policies, where you can interact or interfere what kind of communication should be possible, and even something called pod security policies, where you can limit the pods, means the container that they're executed. On OpenShift, the extension is that you have some things called image streams. Image streams are kind of the golden bullet of OpenShift, let's say. They are known for source to image. You have kind of automatically built triggers that you can deploy within the cluster based on the application catalog. And then you have, for example, in Jenkins that watches the Git repository and pushes automatically in the internal repository of the cluster. As in the further extension, you have something called user management. You have integrations of different identity providers. I will come to this in a second. Something called templates, where you can deploy and specify secure defaults. You have a revision history. If you have deployed something wrong and you want to go back and you do not know or have somewhere the YAML file, for example, lost, you can go like in the revision history back and check what was previously deployed. And a very important thing and a feature that's offered by OpenShift that's very heavy and forceful, let's say, is security context constraints. We will also dig deeper into this topic in a second. But before we talk about the security or insecurity of the cluster, I will specify the threats, what we are talking about. I'm working as a security consultant as well as security analyst. And so if we are on customer projects, we ask the customer what kind of threats exist actually. So for sure, you know the external attacker. The external attacker has only access to like known the public exposed interfaces. For example, the services offered by the cluster. It does not normally has API access and no inside knowledge about the cluster. Maybe there are publicly offered images like on Docker Hub or Quay.io, GitHub, where an attacker may use open source, like open source information gathering, whatever, to get the details about what's deployed. And then on the other hand, we have the internal attacker. What is an internal attacker? An internal attacker might be a malicious developer who wants to harm your system or like your application. Another thing would be you have a supply chain, as previously talked about. You have deployed a container within the cluster that's not produced by you. That can also be kind of an internal attacker. The external company will come and say, okay, you need to deploy this image and you're fine. Yeah, for sure. And then you have the internal attacker within your cluster. This guy might have access to the API, depending on the configuration of the deployment. So you can specify on cluster level what kind of API access the deployment should have. Then depending on the position of the container and on the access, it might have influence on the control of the deployments of the images. It might have access to external, like to the code repository, and based on information gathering, you can get internal cluster knowledge. Yeah, but now we are here. What is the difference between an external and internal attacker? If we are going to analyze such a system, we think, okay, the internal attacker is just only one step ahead of an external attacker. So because as soon as an external attacker has compromised container, it is like one step further and is the same position where the internal attacker is already. He might have access to the API, control all the images, maybe, and based on information gathering, he can access cluster internal knowledge. So now let's talk a bit about the security and insecurity of clusters. There's talk from Brett Giesman from the KubeCon from 2017. I stole the slide because it was a pretty good overview. You have kind of low-hanging fruits that you can introduce into your cluster and some higher levels, more advanced things. Today we will talk about these features that are offered by Kubernetes, like we will talk a bit about the security policies, role-based access control, and least privilege principle, how it is solved by OpenShift and how it's maybe not solved. And the first, we will go for user management, then we talk about the network security, and then we will dive into the security context constraints. I'm a bit in a rush because I have a lot of content, sorry for this. If I'm too fast, just interrupt me or come on later and ask me if you have questions. But for now, we will talk a bit about the user management. OpenShift offers a lot of identity providers by default what you can integrate into the cluster. For example, you can integrate from OpenStack, Keystone, LDAP authentication, or even something like Google authentication, GitHub, GitLab, whatever. It's important to say if you configure your identity provider, you must know that the mapping method must be specified within the identity provider. You have something called the implicit mapping, it's a claim, and the explicit method, and that's the lookup. In an implicit mapping method, the claim, that means everybody who is defined in the identity provider is automatically looked up by the cluster if the user wants to log into the cluster, it's looked up in the identity provider and get access to the cluster. This means if you do not have further topics, I will come to this later, further measurements implemented, everybody who's in your identity provider might have access to your cluster. So it's always a recommendation to go for the explicit mapping by lookup. What's the difference? Identity is managed by the identity provider, and the user is the object, the vice versa object within the cluster. So if you are talking about a user, you are talking about the object actually in the OpenShift cluster. A great benefit is that you can use groups to organize users and manage about the permissions. We come later to this, and even synchronizes with LDAP. If you have introduced groups in your identity provider, you can ensure that not everyone gets access, except those who are in a certain group. So that's also a way to prohibit the access. And if you do not have such groups, you must keep in mind if you use to delete the user in the cluster and he's still existing in the identity provider, the user can come again from the identity provider, log in, and he is still again in the cluster. So it's a very important thing, just go for an explicit mapping and not for an implicit. By default, we I analyzed with my colleagues the default cluster configuration of OpenShift. By default, a lot of roles are introduced by the cluster, and it's by the documentation recommended to not modify these rules because it might break the cluster. If you want to add additional functionality or reduce them, just introduce new groups and do not modify existing one. So as soon as you are logged in as a user into the cluster, you are implicitly associated with two different groups called system authenticated and system authenticated OAuth. What does it exactly mean? If you go for a group listing, the groups will not show up. These are implicit and virtual groups. What does it really mean? I will show you in a second. I've prepared some live demos as screencasts because it might be the case that I'm not typing too fast and it will not bother you. So first of all, we will log in as an administrator, and then we will try to identify what this virtual group system authenticated have for role bindings and identify which cluster roles are associated with this group. And if we go to the list, we have, for example, the basic user, cluster status, but even the self-provisioner group. And think you, okay, self-provisioner group, what does it mean? Okay, now let's inspect this cluster role, and then you see you have the policy object go, and you are able to create project requests. What is actually a project request? We log now in as user 1, and we try to create a new project and send a project request with new project. And here we go. Imagine you have a user that's in the identity provider and has now access to the cluster. In the default configuration, you were able to go for new projects. And if you do not have blocked it or configured, you were able to create new projects. Based on the new projects, if you get a new project by the cluster, you have by default roles within this project. They're the deployer, the builder, and the pullers. These are more like the default roles that are supplied, for example, for a Jenkins deployment, and even the admin role. Oh, pardon, jetzt. Sorry. No. Oh, this was a mistake, sorry. I hope that this not will happen, but yeah. So we have to wait a second, sorry. Exactly. You have the project request here, then we log in as a user 1, And now we are able to create a new project with OC new project. And within this project, we are even now able to be part of this group admin. As you can see here, the user 1 is in this admin group. And now we are able to even deploy pods within the cluster. As you can see, here is our user pod that we have been now put into the cluster. Now you can say, what can probably go wrong? OK, users can now go and deploy workload within the cluster. OK. Is it only the real problem? OK, let's figure out what can be not also be the problem. If we inspect the normal configuration of a deployed pod within the network, and you go into the resolve configuration file within the etc directory, you have the search domain. And have you ever spent that much attention to the search string? Here on this level, first we will search in the namespace and then on cluster level. And if you have deployed a service on on the namespace level, you might the user will automatically the DNS service will automatically look up within the service namespace. I figured out there's a very nifty bug. I had a video for this, but I have to perform it live because I realized it's even worse. I have to check if I have access to my infrastructure. No. Sorry, that's unexpected. I have to connect to my company. So now I'm in user 1. At first, I will log into my cluster as user 1. And from here, I can now create a project, for example, with the name com. And sorry? It's not shared. Pardon. Is it now possible to see? Yeah, I think. Sorry again. First, we will log into our project as user 1. And then we have created a new project with the name com. In this project, I will deploy a known pod that I have specified beforehand in my demo directory. And the pod will have the host name Google and the subdomain www. And even, I will create this pod. No. That was a mistake, sorry. We have to wait now till the container is stopped because I started the wrong one. No. So we created a pod which is actually running in the cluster. And now we will create also a service for this pod on port 8080. And now we will change the workspace to use to that in the other project. So moment. In this workspace, I've previously started a container, and if we do now a curl on www.google.com, the request ends up in the namespace that we just have created. On this way, we are able to interfere the DNS lookup of a cluster. Can you imagine you have a build pipeline, you have a Jenkins within the cluster, and another user can create a new project within your cluster with the project name or namespace, how it's called on Kubernetes level, with a namespace name com, and spin up a service like Google, and every DNS request is first going to his namespace and not to the public internet. That can be a mandatory thread within the cluster. Now we can go back to my slides. Does it now work? Verdammt. Yeah, so it's good. Sorry. It was a demo. If you want to prohibit such threads within the cluster, you can go and patch your default policy within the cluster and remove the self-provisioner role from the system authenticated. The other way would be just define per pod, on pod level, a dedicated DNS policy where you can influence how DNS lookup is performed within the cluster. Okay, let's go to the next topic regarding network security. By default, OpenShift offers certain network security plugins, this means OpenVSwitch Subnet, Multitenant, Network Policy. What the three plugins mean, I will come to this in a second. In general, in OpenShift, the master does not participate within the node network. If you have spin up your pods within the network, say per node you have a dedicated class C network. That's a way to identify what's going on and where to shift the traffic, route the traffic. The overlay communication is built on VXLAN, and if you want to integrate other hosts within your cluster, you can integrate them as an OpenShift node and define them and taint them that there's no workload schedule on the system. Then you have the network integration, or you can even implement a VXLAN tunnel endpoint on this device. By default, the OpenVSwitch Subnet plugin is absolutely not recommended because by default it doesn't offer you any security. Which means, as an attacker, or just let's say as a normal user, we can start our workload. We have the same hello pod again. We will start up with just a hello world. This pod is exposed within our namespace as hello, and here's the cluster IP. So as an attacker, we are now user 1. We go and run our own attacker pod as user. We connect to this pod. And what we now can do is we use cluster functionality and make a reverse IP lookup on the cluster IP address. Kubernetes service host is a default environment variable that comes with the cluster to you. And if you put a /24, you have the class C network where the default services are run. We can use nmap, for example, to make a reverse IP lookup and get the domain names. If we put a /16, we would get every service that's available within the cluster. Oh, not again. Sorry for the demos, it's kind of. The progress bar is missing, so sorry. So we start our container again as an attacker. Then we can go into it, connect. We can make a reverse lookup of the IP addresses, and if we do it on 6.16, we would find the hello container and make a port scan on port 8080, and then we can access from one workspace the network service that's exposed on the other workspace. So we can make a curl request on port 8080 and have the hello world. Imagine you have, for example, an unprotected database, so everybody who has access to this cluster can also access this unprotected database. A way to prevent this is to use, for example, the OpenVSwitch Multitenant plugin. The multitenant plugin separates each project from each other on network level. That means if you try to connect to another service on another project, it would not be possible. And you can even go and join projects together. But you should keep in mind, you only have the separation on namespace level, and projects get a virtual network identifier assigned. And virtual network identifier 0 is more privileged. The default project has a virtual network identified 0. Since the overlay is built up on VXLAN, and you know already the right source, which is by default allowed, like virtual network identifier 0, you might have the first step into the cluster. But there's further research regarding VXLAN security. You can find it later in the references. And the third plugin that's available is the OpenVSwitch Network Policy plugin. In this situation, I would recommend you to go for and like the cluster default for all services and make a deny all policy for ingress traffic. For example, the guys from Monzo has plotted a graph of their network policies with 1,500 services, microservices that are allowed. So it's a huge effort, but you should go for a whitelisting approach. And furthermore, you can go and make a white and black listing on layer 3 so that you might be, so that you prohibit the pods to communicate out of the cluster, for example, to access infrastructure nodes. And another thing that I would like to recommend you is you can configure the egress IP address, which the pod uses to communicate out of the cluster. And also, you can define which traffic is allowed. OK, next step. We will now go to the security context constraints, and I will talk a bit. First, I will give you a short introduction. It was released in the OpenShift release 3 in 2015. The thing is, role-based access control is for service accounts, while you have secure context constraints for the pods. If you want to secure a pod, you will go for secure context constraints. If you want to restrict the users, you go for role-based access control. It restricts the execution of the container, and only the cluster administrator can assign to service accounts these constraints. So if you want to administrate what can be executed within the cluster, you go and create dedicated service accounts for each workspace, namespace where you can interact. The default security context constraint is restricted. As OpenShift comes with a lot of defaults, even there are a lot of defaults by OpenShift. And if you look into the list of secure context constraints, you find any USID. And what especially you can identify is the privileged role. The privileged role is like if you start on a Docker container with -- privileged, or start a container in a normal Kubernetes network cluster as privileged, it's the same. How does this look? I will just let it play and not touch it. Hopefully it will not broke this time. Explain on the side. At first, we will go as a normal user and create a service account, run as privileged. Then we go to our cluster administrator and ask, can you please assign the service account to the privileged secure context constraint? With the -z, you refer a service account. Then the user can go and use the service account within the pod that's deployed within the cluster and specify here a service account run as privileged. And if this This pod is now rolled out. We create a new deployment in the cluster. And with this deployment, we can now communicate and interact on the command line. And as you can see, we are now the root in the container. It's the host name. And if you check the capabilities of this container, you can even identify its effective, inherent, and permitted. And we can even go and show us the host devices of the underlying node. In this case, we were able to mount the host devices into the container, but never hand out the privilege. The next thing where I want to look in is the predefined profiles that allows the access, to, for example, to host PaaS, host IPC, and host PID that you will get an idea from. Okay, this is these three. I will make also a short demo to show the impact of these three policies. First again, the user creates a new service account, run as host PaaS. This role, with this role, we go through our administrator and ask, may you please add this account to the secure context constraints. And as soon as it's added, we can create a new deployment for the cluster. And for example, go and integrate host IPC, host PID, and even go and mount the host file system as host file system. Normally, it's not allowed to do such actions, but if you want to, you have to create it. So now it's deployed within the cluster, and if we now connect to the container, you can see that we have a huge UID because it's randomized by the cluster automatically. If you see the process tree, it's important to note here that we can now interact and see, for example, the other Docker containers, because we have the host IPC space where we can see what's going on. This process, for example, is our process. A big advantage of OpenShift is that you get automatically assigned SE Linux groups, which you can show with PSZ, where you have predefined profiles that restricts the container. And if you now go, you can show the host file system and see here are different SE Linux profiles. And if you want to touch a file in this host file system, the permission is denied. Okay, in this case, it's because we are not root, because we want to touch on root file system layer. But if we were not root and we have a file like temp, we were not able because it's prohibited by SE Linux. Another option is just go with root in the container. And as we know, running processes in a container is normally, as root is also normally not just recommended. So, and if we cut all these out that are not recommended, we just let stay the secure context constraints what we have still, and it's the host network. But if you want to hand over the host network access to one of your developers, normally you don't want to. So you end up with acceptable secure context constraints that are available for the developer, and that's the restricted one and the non-root. My recommendation would be just use only these both context constraints, and just if you want to give special permissions to the user, you should always go and configure your new secure context constraints. And the integration of SE Linux is a great benefit. How a secure context constraint can be created is now shown in this example. As first, I will go again and create a service, run a service UID 1000 because I want to run my container as UID 1000. Then the administrator logs in and has to create a new secure context constraint dedicated for me, where we allow run as, must run as, and then you can specify the UID of the run user. This constraint is created. Then this service account that previously has been created is now assigned to this constraint. And now the user has opportunity to deploy his workloads with this new service account and yeah, run his user ID 1000. Specified here. Now we are in the container, and as you can see, the user's ERNW and the ID is 1000. And again, the restrictions from the SA Linux are still in place here. And yeah, the capabilities are again dropped. Only inherent capabilities that you are able to not interact with the kernel. Okay, that's the end. To summarize it up, the conclusion. OpenShift raises in general the bar of the security of Kubernetes cluster. It's a great benefit, but you should always take in mind just to further adjust it. For example, to not allow creation of own projects. It's very tough as a security analyst to keep up with Kubernetes and OpenShift releases because the extension and adjustment of the cluster functionality is still challenging. It's a weird thing on my opportunity that the features that are developed dedicated for OpenShift are not widespread by now to the community and integrated into the core of Kubernetes. And my next big thing is just analyzing OpenShift 4.2 because there are a lot of rework and maybe have always everything changed, but yeah, I have to verify. Thank you for your attention. That's it.